Good day, everyone. This is Group 3 topic IP Addressing Fundamentals. I'm Engineer Yunelfa Reggie F. Calibara and I'll be handling the report. There are two parts of our report. For the first part, our objectives will be define important related terms in IP Addressing Fundamentals. You should be able to identify the class of an IP address and also classify the network and host section of an IP address, and can readily convert binary to decimal numbers or decimal to binary numbers. To start with, we have hardware address versus logical address. What is a hardware address? This is used to uniquely identify a host within a local network. It is also a function of the data link layer of the OSI model layer 2. Now, Ethernet utilizes the 48-bit MAC address as its hardware address. This MAC address is often hard-coded on physical network interfaces. Now, this MAC address is often represented in hexadecimal using one or two accepted formats, like this. First format is separated with a colon and the second format is a dotted format. Now, the first 6 digits of the MAC address will identify the manufacturer of the physical network interface, or we call it the OUI, Organizational Unique Identifier. The second one, is used to identify the host itself and are referred to as the host ID. Now, what about logical address? Logical address is a function of the network layer of the OSI model layer 3. They are never hard-coded on physical network interfaces and can be dynamically assigned and changed freely. A logical address contains two components: the network ID, which is or will identify which network a host belongs to, and a host ID, which uniquely identifies the host on that network. Examples of logical addressing protocols include the Internet Work Packet Exchange, or the IPX, and the Internet Protocol, or the IP. The IPX was predominantly used in novel networks but is now almost entirely deprecated or is not suggested to be used. IP is the most widely used logical address and is the backbone protocol of the Internet. Now, the Internet needs addresses. Why? Addresses will allow endpoints to identify and hence talk to each other. Addresses also allow routers to determine how to move a packet. And in the network layer, addresses are designed to help routers perform the forwarding and routing functions efficiently. Now, from these resources or reference of Chuck Semeria, we have here some thoughts to ponder. The Internet has entered the public consciousness as the world's largest public data network, doubling in size every 9 months. This is reflected in the tremendous popularity of the World Wide Web, the opportunities that businesses see in reaching customers from virtual storefronts, and the emergence of new types of methods of doing business. It is clear that expanding business and social awareness will continue to increase public demand for access to resources on the Internet. Isn't it? So what is an IP address? An IP address basically is a 32-bit address that uniquely and universally defines connection of host or a router to the Internet. The address space of the IP version 4 or the IPv4 has reached around 4 billion, or 2 to the 32. That means 4 billion addresses is available for use. and this was introduced by IANA, or the Internet Assigned Numbers Authority. This 32-bit address is divided into 4 equal parts of 8 bits separated by the dotted decimal notation, like this. So the smallest possible value of an octet is 0, or in binary, there are 8 zeros because it's an octet. The largest possible value of an octet is 255, or 8 ones in binary. Each of 8-bit group is known as octet, as I have mentioned. So here is an example of that address that we have mentioned in the previous slide, 158.80.164.3, and I'm sure that you can convert this from decimal to binary. So this is our 158. This is our next octet up to the 4th octet. Now, maybe we should refresh the number system conversion. From decimal to binary conversion, we have the simplest method is to use the following table. Why are we going to use this table? Because remember, in IP addressing, there are 8 bits in 1 byte. So there will only be 8 bits. Okay? So 1, 2, 4, 8, 16, 32, 64, and 1 to 8. This table is also true to be used when you are going to convert from binary to decimal conversion. There are a lot of methods of converting this one, but this is another method and a shorthand method. Like for example, if we are going to convert 34 decimal number into binary. So we can do subtraction if you want, or you can also do division if you want. There are many ways, remember. So think that this 34 is a decimal number and that you are just going to subtract any of these numbers starting on your left. So if 1 to 8, can you such that the difference will not be a negative number. So 1 to 8, 34 minus 1 to 8 is not possible because you are going to generate a negative number. 64 is also not possible because this is greater than 34. 32 is, so that means 34 minus 32. This one is possible. You are not going to generate a negative number. So that means if the subtraction here will generate a positive number, then that number on your table is possible or will be 1, become 1. Okay, we are going to, it's like a switch, you're going to on it. The other numbers where subtraction will generate a negative number, then we put it into a 0 value. Okay, so here 1 to 8 is a 0, 64 is a 0, 32 is a 1. Then the difference here is 2 minus 16 is not quite possible, so we put 0. 8 is also the same, 4, and the 2 is possible, so we got a 0 number answer. So this is a 1, and this becomes a 0 also because we will generate a negative number here. So finally, your answer for this decimal to binary conversion of 34 is this 001 00010, or you can say, because this one is 8 bits, so it should be 8 bits or 8 digits. Now, for binary to decimal conversion, you are going to use that table again, given this binary number. So how are you going to deal with this? So all you have to do is add the columns with a 1. Okay, so the one with a 1 is the 1 to 8, the 16, and the 2. So the sum is 146. So that easy to convert from decimal to binary or binary to decimal. This is just a refresher so you can review your past courses. Now, continuing, we have what we call a classful IPv4 addressing. So there are different classes of IP addresses. So the first we have the class A. This is for very large organizations. This one can generate up to 16 million hosts that is allowed, or 2 to the 24. And the first octet range is from 1 to 127. The default subnet mask is 255.0.0.0. So this one is the how it will look like with your subnet mask. The first octet is a network address and the rest will determine your host addresses. Class B is for not so large organizations. It will allow 65,000 hosts connected to this network, and the first octet of the range will be from 127 to 191. The default subnet mask is 255.255.0.0. So this is how it will look like. The first two octets is the network octet and the last two is the host octet. To follow is the class C. This one is for small organizations. Usually we use this one. So it allows up to 255 hosts and the first octet range is from 192 to up to 223. The default subnet mask is 255.255.255.0, and this is how it will look like. The first three octets is a network address and the last will generate the different host addresses. For Class D and Class E, we are not likely to use this, especially the public. So Class D is a multicast addresses. There is no network or host hierarchy here, and the first octet range is 224 up to 239. There is no subnet mask for this one. The same is true with Class E. For Class E, this is reserved for experimentals and used for research. The octet range for the first octet range is from 240 to 255. That means these first octet range numbers will determine or will allow you to identify the class where that address belongs. Okay, remember again, the first octet range numbers in your IP address will let you identify which class that IP address belongs. Now, subnet mask. What is a subnet mask? A subnet mask is part of an IP address identifies the network. The other part of the address identifies the host. Remember, there are two parts of your address, IP address, the network and the host. Now, a subnet mask is required to provide this distinction, so you would not know until you will have a subnet mask. So you have to identify the class, and when you are going to identify the class where that IP address belongs, you are able to identify the default subnet mask. The above IP address has a subnet mask of 255.255.0.0. Why? Because 158 belongs to class B, right? The first octet range. This one, 158. Okay. So the subnet mask follows two rules. What are they? This one is our default subnet mask. If a binary bit is set to a 1 in a subnet mask, the corresponding bit in the address identifies the network. If a binary bit is set to 0, then in a subnet mask, the corresponding bit in the address identifies the host. So that means if this is your IP address given 158.80.164.3 with a subnet mask, default subnet mask of 255.255.0.0, then if we're going to convert this IP address into binary numbers, then you will generate this IP address. And also for the subnet mask, if we are going to convert this one into binary numbers so that you can easily identify and check where is the host address in your IP and where is your network address. Okay. So the first 16 bits of the subnet mask are set to 1. That means from left to right in the subnet mask, these are set to 1. So that means the first 16 bit of the IP address is or will identify the network. So the network of our IP address is 158.80 because all in its subnet mask is set to 1 on the first 16 bits. The last 16 bits of the subnet mask are set to 0, thus the last 16 bits of the address identify the unique host of that network. So this is your host address 164.3, but the whole IP address is 158.80.164.3. So remember that hosts on the same logical network will have identical network addresses and can communicate freely. And hosts that are on different networks cannot communicate without an intermediating device, thus will need a router between them. Routing is the process of forwarding packets from one network to another. We have another term, classless interdomain routing, or the CIDR, is just a simplified method of representing a subnet mask. Instead of writing 255.255.0.0, this CIDR will or can identify the number of binary bits set to 1 in a subnet mask preceded by a slash. So instead of writing the subnet mask, all you have to do is just write the IP address slash this one. That means there are 26 bits in this subnet mask that is allocated for your network address. So later we will see that one. Now another, we have a differentiation between address classes and subnet mask. So there are three rules that we have to remember when we are going to differentiate this. As that, the first octet of an address dictates the class of that address, as I have said before. Then, the subnet mask determines what part of an address identifies the network and what part identifies the host. And each class has a default subnet mask. A network using its default subnet mask is referred to as a classful network. We also have private versus public IPv4 addresses. What are these? A public address can be routed on the internet. Thus, hosts that must be internet accessible must be configured with or reachable by public addresses. The allocation of public addresses is governed by the IANA. For a private address, this is intended for internal use within a home or organization and can be freely used by anyone. However, private addresses can never be routed on the internet. In fact, internet routers are configured to immediately drop traffic with private addresses. So these are examples of private addresses in class A that you can use freely. You can within a certain organization. For class B, if you are seeing this network, and for class C. Now there are also special address ranges. What are these special address? That means you cannot use them as a host or a usable host. We have a loopback address. Only the single 127.0.0.1 address is used. Addresses 127.0.0.0 up to 127.255.255.255 are reserved. Any address within this block will loop back to the local host. Another, we have the linked local addresses. Here, IPv4 addresses in the address block 169.254.0.0 up to 169.254.255.255 are designated as linked local addresses. Testnet addresses, these are also address blocks between 192.0.2.0 up to 192.0.2.255. This is set aside for teaching and learning purposes. And for experimental addresses, somewhere in class E, these addresses is in the block 240.0.0.0 up to 255.255.255.254. These are listed as reserved for future use. This is the end of part 1. Thank you for listening.